Hello and welcome. My name is Oleg, I'm a certified Unreal Engine instructor and I teach real-time graphics. In this session, called Technical Arts and Python Scripting in Unreal Engine, we'll explore how Python can help automate tasks in Unreal Engine. We'll also look at the role of technical artist and the skills you'll need to succeed in this area. By the end of this tutorial, you'll understand how technical artists use Python scripting, what skills are essential for automation in Unreal Engine, and you'll see practical examples of preparing legacy Unreal Engine 4 projects for Nanite and Lumen in Unreal Engine 5. I expect you to know about Unreal. Also, I expect you to know a little Python, but if not, don't worry, I'll keep it simple and share resources for learning Python later. So, why automate? Automation saves time by eliminating repetitive tasks. For example, you can automate asset management in your content browser, or actor management in your levels. If that sounds useful, or if you want to become a technical artist, this tutorial is for you. Speaking of technical artists, a technical artist bridges the gap between artists and programmers in games, animation and visual effects. They make sure the artistic vision works within technical limits and solve problems during production. What is one key skill for technical artists? Knowledge of programming or scripting, and Python is a great place to start. Unreal Engine supports scripting through blueprints, C++ and Python. So why Python in this case? Python is widely used across the industry. It's used in Maya, Houdini, Blender, Nuke and more. It's easier to learn than C++. It works cross-platform and has tons of libraries and community support. In Unreal, Python is perfect for automation tasks in the editor, like creating asset management pipelines and workflows. It even can procedure manage the Unreal editor itself. But please note, Python doesn't work in runtime. No endgame scripts, no interactive blueprints. Today, we automate two things. First one is enable Nanite for all suitable assets in a legacy project, and second one, prepare light sources for Lumen. Our example project is Epic Zen Garden, originally built for Unreal Engine 4. We'll open it in Unreal Engine 5.6 and upgrade it. Before scripting, we're going to enable these plugins: Editor Scripting Utilities and Python Editor Scripting plugin. Please note that in recent versions of Unreal Engine, this might be enabled automatically for you. In Editor Preferences for Python plugin, I'm going to enable Content Browser integration, and later I'm going to ensure that Python folder created in Windows Explorer is synchronized with the engine by selecting this option. These settings require me to restart the engine. While it's restarting, I can note there is another checkbox for developer mode, which allows setting up autocomplete in external text editors. Let's start simple. In the output log for the Python, I'm going to type print, open brackets, open quote, hello world, close quotes, close brackets. Press enter and you see hello world in the log. I can notice that the Python plugin created the folder for me in the content browser, but this folder is not linked to the folder on my hard drive yet. I will create a Python folder inside the content folder for the project to keep space for my scripts edited with external editor. Let's create a file called tutorial.py in your Python folder and add the same line. To have the first step of enabling features of Unreal Engine 5 for the legacy project, I go to Project Settings and enable Shader Model 6 for Nanite support, and switch global elimination for Lumen. Again, I need to restart the engine. Please note, if you keep your scripts inside your project, then it makes the project better portable. So for the portability, I would suggest you to use the Python scripts inside your project and inside your contents folder. Switch to Unreal Engine and right-click. You can see Run in the context menu. Run the script and see the result. I'm not going to discuss the Python language. There are other courses and websites for that. If you want to learn Python, I would recommend the courses from W3 Schools or learnpython.org. We will use basic Python today. Indentation for blocks of code in functions, loops and conditionals. Variables with dynamic typing. Basic data types, mostly Boolean and lists, but there are more data types in Python. I'm going to define functions with the def keyword. I'm going to use loops, in particular for loop, and I'm going to use conditionals, if statement. When I'm typing comments, I will start them with hash symbol. For external code and libraries, I'm going to use import to import module. Finally, I'm going to access properties with dot notation. For Unreal scripts, we always start with import Unreal. That gives you access to Unreal Python API. Speaking of which, the Unreal Python API is your best friend. Check the docs at dev.epixgames.com and make sure you're looking at the right version. And you can see the right version in the URL. If you remove the version number from the URL, it will land to the Python API for the most recent version of Unreal Engine. In my case, that's 5.7. But please note, I'm going to work with 5.6 to make sure that I've got consistent API and the project. Let's keep it simple and look at editor asset library, which is a utility class to do most of the common functionalities with the content browser. I learned about this function by checking the Unreal Python API, and often that's the best way to learn. Please note that in the Unreal Python API there are classes containing data and method functions, and the documentation states what these functions take as an input and return. The function getProjectAssetDirectory should return the root directory for the project. Let's check it. For editing my Python files, I'm using Visual Studio, but you can use any code editor you want. For example, Notepad++, Jupyter, Idle, and so on. I'm going to use the print function and prints whatever this function returns. So, I can see that the function prints me game. Good. In editor asset library, notice the function list assets. It takes the path as an input and returns an array as the output. Let me check the function, and I'm going to do that. I'm introducing variables to my code to improve the readability. I made some errors in the code, and if you have errors, don't panic. Every coder makes mistakes, but every good coder knows how to read the error message and understand what was wrong and how to fix it. I'm currently receiving no output. I can see the error, and I'm wondering why. So here's some advice for technical artists. The API is not perfect, and you need to develop your problem-solving skills. By examining the documentation for get project root asset directory, I see that it should return /game/, but in my case it returns just game without any slashes. What if I manually add the slash into the code? Extend our script by printing every item in the list using for loop. After doing so, it works. And I can see all the assets in this project printed for me. Good. Now I'm going to change the text a little bit more, introduce the function, and isolate it as the function. So I've got the quick script to list all the assets in my project. I will rewrite the code, introduce some variables, and improve readability. Please notice that I'm using some coding style, and using coding style is another quite good property of the good technical artist. So comments, clear variable names, functions, and so on. Good coding standards make your script easier to read and to maintain. This code represents the first step for our first case study. I will save this file as nanite.py. It's worth noting that it will automatically appear in the content browser. Before going further into the scripting, let me summarize Nanite in brief. Nanite is Unreal Engine's virtualized geometry system, which is documented in detail at devepicgames.com. A mesh is a good candidate for Nanite if it meets any of the following criteria: many triangles, all triangles that appear very small on the screen, or it has many instances on the scene, or it acts as a major collider, or it acts as a major occluder for other Nanite geometry. Or finally, it might cast shadows using virtual shadow maps. Nanite supports quite a few of component types like static mesh, skeleton mesh with the exception of morph targets, spline mesh, instant static mesh including hierarchical, and geometry collection with foliage painter and landscape grass. However, there are limitations. Nanite supports only opaque or masked blend modes in materials, and that's what we're going to check for our meshes. So, my goal is find all the meshes, and I'm going to focus on static meshes this time. Check if the materials use opaque or masked blend modes, and enable Nanite for all suitable meshes. I should note here that another valuable skill for a good technical artist is algorithmic thinking. That means you understand the problem that needs to be solved and can break down the solution into actionable steps and the execution sequence. You should also know which steps require further subdivision into smaller tasks. Currently I've got a function that lists all the assets in my content browser, and I'm going to modify this function so that it only lists assets of a specific type provided as a string. I will introduce a variable named return assets of the type list to hold the list of relevant assets. Additionally, I will check the functionality of the asset data class, and the asset data has asset class path, asset name, and so on. And by the way, note that asset class is deprecated, and we should not use that unless absolutely necessary. Use asset class path instead. So asset class path. if statement will check if the asset of the type that I need. Clear the log and check if everything is functioning as expected. So it prints me quite a few of assets and they look like they're all static meshes. So hopefully this script works. And note that I will embed variables for my print statements using fstring format to replace the variables with the values. And I will use the append function to add items to the list. Let's test this function by printing all the assets of the type static mesh. I'll call this function read Nanite data and extend it later in this tutorial. Now, when we look at asset data, the getAsset function allows us to retrieve the object. If you think about object-oriented programming principles, and if you don't know about object-oriented principles, then once again go back and check the tutorials about Python language. So, in object-oriented programming principles, we know that the object can be derived class. So, if we get the object, it can be not the object itself, it can be the model of another derived class like static mesh. So can this object be a static mesh? Let's find out. Inside the static mesh, we can explore the Nanite settings property that gives us access to the mesh Nanite settings class. Within that class, we'll find a Boolean variable called enabled. In Unreal Engine documentation, it states that we should use getEditor property to retrieve values and setEditor property to modify them. You can easily locate documentation for these functions as you go. Also, please note that for some objects, I'm going to call the functions directly from the object, and for some objects, I need to create an instance of the object. For visualization purposes, I will enable Nanite for one asset and set up two panels in my viewport. One will display the Nanite visualization, allowing us to see the effects, and another one will be normal perspective view. I'm going to enable Nanite for this asset. And please note that I checked the Enable Nanite's box in the Static Mesh editor, and also I clicked Apply. I applied these settings. So while working with assets in my script, I'm going to do the same two steps. Next, we'll focus on checking the materials associated with our static mesh. To get the list of materials, we can use the Static Mesh Material Editor property. Just a note, while using dot notation, I still can access properties, but remember that these properties will likely to be read-only. And if you want to access properties for reading and writing, you need to use getEditor property and setEditor property. Static materials editor property returns the list of static materials. And in static material object, we can find it contains material interface. If we look at the material interface, we can see that it's got the property called blend mode. So I'm going to create another function to check whether the material has a blend mode of either opaque or masked. We can iterate through the lists to obtain the material interface. So it prints me a couple of materials. Nanite enabled, mesh material suitable. Similarly, for some of the materials, I've got the non-type as an input. I should note, in some cases you might have errors and you want to avoid these errors instead of handling these errors. So I'm going to use a try except block for this function. Now we have a list of assets when Nanite is disabled. So I'm going to enable Nanite for all static meshes using my script. So I'm going to not just read this Nanite data, but modify Nanite data. I'm starting with the assumption that all materials are suitable, but if any single material doesn't meet the criteria, we'll use logical AND operation to set our material suitable variable to false. And please note that logical AND in Python is denoted by symbol ampersand. And the logic is the same. I'm checking if all the meshes are static meshes. Then I'm checking if meshes don't have Nanite enabled, and if the material is suitable for Nanite. Again, I'm using if statement to check if both conditions are met. If I've got material suitable, and if Nanite is not enabled. To apply these changes, I'm going to use another object called static mesh editor subsystem, which is essentially Python API counterpart of the static mesh editor window. And in the last arguments, it takes true or false for apply settings immediately. And in the last argument, it uses true or false to apply the settings immediately. And I'm going to use that function exactly. So this code probably requires a bit of commenting, and I'm going to add it like now. Finally, run the code and check if it works. If this tutorial is not the first one you found out about the scripting, you probably noticed that all the code is different for different tutors, and that is absolutely normal. Likewise, the algorithm in my case could be different, and the logic could be different. So, for example, I could extend the criteria by introducing something like polygon count, and also I could include skeletal meshes and check if skeletal meshes don't have morph targets, and so on and so forth. But the main goal of this tutorial is provide you basics and provide you the way, and then you should be able to follow the way and extend the code by yourself. But now let's move to the next problem, ensuring the scene is ready for Lumen. Lumen is Unreal Engine's real-time global illumination system. It works with Nanite and replaces statical light maps. It provides high quality of visuals, but it does require more GPU resources. It can reduce noise for small emissive objects, and it relies on distance fields and capture impacts, light accuracy, and performance. But for us, the most important aspect is that all the movable light sources are compatible, but it doesn't work with static light sources. That means if the light source has static mobility, Lumen doesn't know how to handle that properly, and we can have unexpected results. So our goal is to find all the light sources at the level, convert directional light sources to stationary, and convert others to movable. Why only directional? Because there are usually a smaller number of these light sources. If we convert all the light sources to stationary, we can find out that light sources can overlap with the attenuation, and if we have more than 4 light sources overlapping, then they will be visualized as disabled. And even though in Lumen it's not an issue, it still can confuse users, and we don't want confused users. That's why I'm going to convert only directional light sources to stationary, and all the rest will be movable. So I'm going to open my tutorial py and save it as lumen.py. For this exercise, I'm going to use editor actor subsystem that works with actors. Once again, I can go to the documentation and find out everything about this editor actor subsystem. Inside documentation, I can find the function getAllLevelActors. So the first exercise will printing all the actors inside my level using editor actor subsystem. And I can see that all the actors inside my outliner are eventually appear in here. And by the way, notice that even though my level has sublevels, I've got all the actors from all the levels and sublevels as well. Also, in documentation, I can see that there is a function to list all the components. And if I think about that, technically speaking, I can check on the components for now, because all the actors include components, and components might be more than just components of the actors. What I mean by that? I mean that in some cases we have blueprint objects, and these blueprint objects can have light sources as their components. But if we get just light sources, they also have light sources as the components. What does it mean? That means that I can check on the components, all the level components, and then find out if some of them are light components. So now I'm going to modify the function to check if my components are of certain type. This time I will be using the Python function isInstance to compare the type of the object against the one I need. Next, I'm going to create a function that checks the mobility of the light component. The available options are stationary, static, or movable. And you can see that in Unreal component mobility enumeration. Now, let's convert all directional light sources to stationary and change the rest to movable. Remember, we'll be using the setEditorProperty method for this task to predict issues with read-only properties. So now it's time to run the script and see the results. You'll notice that dashing lights are now stationary, while all the other lights has been set to movable. Before we conclude, here are some final recommendations for using Python using Unreal Engine. First of all, Python data types such as arrays, lists, set, and dictionaries can automatically to Unreal API types, so you don't have to use extra casting. And in my case, I was using array from Unreal API as a list in Python. And in general, use Unreal types when possible. And also use Unreal Python API functions when possible. So avoid using modules from Python like os, chutil, and so on that work with files on your hard drive directly. When working with objects, you can use Python object-oriented programming functions isInstance and type to test whether an object derives from or matches a given class. Important thing to note is that API can change, so please use the same version of API that corresponds to your version of the Unreal Engine. And finally, the Unreal module exposes nearly everything that is exposed from C++ to blueprints. That means that if you get a plugin which is written in C++ and which exposes some functionality to blueprints, that means that functionality will be available to Python scripts as well. And that's about that. So what you've learned? You learned about the basics of using Python for automate tasks in Unreal Editor. You got some insight into Unreal Python API. And I hope you feel more equipped to step into the role of technical artist after the session. So thank you for watching, and we'll see you next time. Until then, happy coding!